Good morning. Really, it's morning. I don't know how good is it for some of us. I see there are much more people than I expected because it's morning, the second day. The second day is the day after the first evening, so it will be hard for someone to awake too early. But anyway, this year I will talk about the new features in the SQL language, which is expected to see, which is implemented in the new version of Firebird 3. This is the mostly the same session that I speak in the past year, but it was a bit refreshed. Maybe it will be interesting for some of you who was at the conference here the past year. Maybe it will be interesting to refresh the memory. Maybe someone does not listen it, so let's start. The first section of the presentation will be dedicated to the new features in the common SQL language. Common language, I mean, is the language it's used in PSQL and regular SQL statements. So let's see what's new here. The full syntax of the merge statement was implemented. The syntax is not our invention. It was taken from the standard, from the most current standard SQL 2008. Our extension merge turning was implemented. The big feature which was awaited by many people is window functions, also known as analytical functions. Also from the standard we take the new feature for the substring function. Now substring function could work with regular expressions. New BOOLEAN data type, which was asked by many people for the some years, was finally implemented. New pseudo-column for all the relations was introduced. This column is RGB record versions, and it shows the number of the transactions which was modified the version the last time. Also, we addressed some issues with cursor stabilities with the data modification queries. I will speak about it in details. And there was some improvements in the global temporary tables area. Then we will speak about what new you will see in the procedural SQL language. We implemented SQL functions, also long-awaited feature. We implemented subroutines, external functions, procedures and triggers on the non-SQL languages also is supported. We speak about it, if I remember correctly, more than 5 years, but finally the feature included in the Firebird 3 version. SQL packages, very nice feature taken from the Oracle, was implemented. We extended way how exceptions could be used. Now exceptions have the parameters, and I show you how you can customize the exception text in the runtime. In the event handler, error handler for the PSQL statements, we support new SQL state of the error. And in loops, we implement continue statement. Also, many people ask about it for the many years. In VDL language, there is not very much extensions, but some of them are very useful. We want to disable direct changes in the system tables, and we want to cover all the possible changes that people trying to do, modifying system tables. So we found that column A domain nullability was not, there was not a direct SQL statement to manage nullability of columns, so we implemented it. If you know some another use of the direct modification of the system tables which are not covered by detailed statements, please speak about it and we will implement correct statements for it. For the database, it is now possible to set default character set, not only when database created, but you can change it after the database was created. We implemented identity columns. The feature was asked by the people who migrate from the MySQL or MS SQL service where the feature is present. For the better covering of the language, we implement recreate sequence and recreate generator statements, and just to make it language more full. And most interesting feature is DDL triggers. Triggers for the DDL statements, for DDL events. We will look how it works. There was some improvement and some new features in the security area, which also could be speak about from the SQL language point of view. There was introduced a new virtual table with the list of the users from the security database. There was implemented support for database encryption, grant create and grant role to role is still not implemented feature, but we expect it will be implemented before the beta. I hope this feature was donated by the Red database, and we just need to review it and integrate into the Firebird. Monitoring tables, there is already committed improvements in this area. There is many plans for it, so we could expect that in monitoring tables we will extend statistics which could be queried from it. There could be query plans in monitoring tables and maybe something else. This is feature to be implemented, and I don't know much details so far. So this is not all the features. I speak mostly about the features which is already implemented, but not features which is planned for the Firebird 3 is committed currently. It may be implemented, but in the private source tree of developers. So it's not the end, and things will continue. Maybe next year I extend this presentation by a few more slides. So let's look at the details. In common SQL statements, the match statement was extended to have the full support of the current standard syntax. You see in the red color what was new, what was added. We implement additional slash conditions for matched and not matched clauses, and matched clauses we added support for the delete clause. It's better to see an example how it will work. Imagine you have some log table which logged some operations from the another tables, and you get this log and you want to roll up this log into some table, maybe in different database. And the log has the column with actions, for example, insert, update, delete, presented by the character IDU. This is often used by the developers, and you can in one statement perform necessary actions to roll up this log on the target table. Using when matched, you can update column or record or delete record with this set in the log actions, or you can insert new record in the target table. I hope this feature will be used and you will like it. About returning clause, it's just to make our syntax more consistent and more powerful. It still not support result set. It's just for the it works if you modify or update or delete just one row. But anyway, we decided to have support for this returning clause. We have it in the insert statement, in update statement, and merge statement also. It's good to have this returning clause. Well, about window functions, there will be more detailed session by the Philippe, so I will just speak about the syntax and about I show just basic example of how to use it. Window functions is the functions which work like aggregate functions, but it work over the whole result set or over the part of result set. So you can speak that argument of this function is not just current row value, but the values of the many rows of the whole result set, at the part of the result set. Specification of window function consists of two types, of two parts. The first part is a window function type. It represents the function itself, which function do you want to use. And over clauses specify over which part of the result set or the whole result set this function should be applied. There is a few types of window functions. There is aggregate functions. There is rank function, little leg functions, and so on. I will speak about it. Philip will speak about it in more details. I will show just a few of them. This is the full list of the window function which is currently committed, and you already could try it. A usual set of aggregate functions with our custom function list, rank and dense rank, which represent the row number position in the result set, lit or leg function, which allow to get values from the previous or next function row in the result set, first or last value, nth value. Okay, I hope Philip will explain it in detail. I have no examples to show. And second part of the window function specification is the window specification. Window specification could be empty. In this case, window function will work with the whole result set, which is returned by query where function is used, or window specification could partition result set by some columns, and in this case, window function will be applied for the every partition of the result set, which is specified by the values in the list of columns. Also, there could be specified order for the window function. Some window functions, such as leaf and let and first value, nth value, it depends on the order of the rows in the result set. So you can specify order by the window specification. Maybe it sounds very complex, but let's look at a very simple example. I have a table with 6 rows and columns A, B, and C. If you look only at these columns, you will understand what the table contains. Let's look at the first window function, sum C over empty window. Empty window specification means the sum works for the whole result set. So if you look at the first column, is named sum, you see that it has the sum of the values of the column C in the every row. This is expected. So you could use it, for example, to have to calculate the percent of the value of column C over the whole result set if you divide 1 by the second. The second example, the sum C over the order by A and B, show how it could be used with the ordered result set. If aggregate function specification contains a window which ordered, then aggregate function work with not the whole result set, but only with the number of rows which is currently processed. So in the first row you see the sum of the first row. In the second row you see the sum of the first and second row, and so on. I hope it's clear. I'm not sure if my English is so good to make you understand it. Well, the next example is how a window could be partitioned. One. Yeah. It's produces the whole result set. There is no group by here. Yeah. It computes the whole result set, the whole window. It's cached in memory, and we have the almost the same window specification, so it's worked with the same cached result set and compute the window functions. So you will see in the plan just one access. Continue about partition of window. So in the third window function, sum C over partition by A, we see that sum computed for the every distinct value of in the column A, and we have distinct sum. So for the values of A in the first three rows, we have distinct sum, and so on. I'm not sure it could be seen here, but every partition has a different color on the slide. The first three rows is rose, then green, and the last row is yellow. Is blue, but I'm not sure it could be seen blue. And last example is window which is both partitioned and ordered. So we have sum in every partition which is calculated for the every partition distinctly, and we have aggregated sum. Well, if you have no questions, I will go next, and I hope Philip have much more clear explanation for all of this. Well, the next feature, substring search using regular expression, is also sound complex, but if you like regular expression and if you often use it, I don't think you will have some hardness with it. The syntax is very simple. We have substring, we have some string where we want to search. We have some pattern which is used to search the substring, and we have escape clause which is mandatory in this case. In the usual similar to operator, escape character is not mandatory, but here it's the important part of the whole algorithm. The pattern should consist from the three parts. These three parts is the patterns itself, and it should be separated using the escape character and the double quote. You see in red, this is special to see it in noisy way. The three parts of the patterns we could name as prefix, suffix, and matching part, and we have escape character. How engine makes the search itself? The hold the string. At first step, engine check if the hold the string is similar to the hold the pattern without the dividers, without the escape character and close. If the first statement is true, engine will go to the next step. If no, it return null, if I remember correctly. At the next step, the engine should find the prefix of the string, which is similar to the prefix of the pattern, and this first part of the string is trying to find the largest part which is satisfied this requirement. But it's not all. The rest of the string should be similar to the rest of the search pattern. So this is not the simple process. At the third stage, engine in the same way looking for the suffix of the string which is similar to the suffix of the pattern, and the rest part of the string, the middle part, should be similar to the middle of the pattern, to the matching part. If such string could be found, then middle of the string is the result of our stage. To make it better understand, I think it's very simple example. I don't know if it's really simple. Often people ask, I have for example, building numbers in the table. This is character field because those numbers could have number and characters and so on. And I want to extract the real number. I don't need this character, I need a number. So I want to get the some string and extract from them a number if it consisted. So this example did exactly solve exactly this task. I have a pattern which have in the middle part a very simple pattern to find numbers. It could be signed numbers and it must contain at least one digit. And here we see the three steps which engine made to evaluate this expression. The first step is check if the string is similar to the wall// pattern without the escape symbol. At the first step, it found the largest prefix, which is similar to the prefix of the search string, and in the same time, the rest of the string is similar to the rest of the pattern. And at the third step, it found the largest suffix, which is similar to the suffix of the search pattern. And in the same time, the rest of the string is similar to the matching part of the pattern, and you see the result. It could be sound somewhat complex, but this is not our invention. This is how SQL standard defines this functionality. So you can ask how to use it, but please don't ask why it's implemented in this way. It's just because standard dictated. I know that in different database systems there is different way to work with regular expression, with the search using them, but we look at the standard at the first place. So, well, if there is no questions, we'll go to the next part. This is more easy part. Someone could say, oh, it's a feature that I waiting for a long time. Someone could say this feature that does not cause the effort which was made to implement it. But anyway, it's implemented, it's here, so if you want it, let's see how to use it. It's very simple. Data type, we have new word boolean, we have new literals. It's the same literals as null literal. You can use it in expression, in SQL statements, true, false, and unknown. The storage is just 1 byte, and at client side support we introduced a new SQL type for the XSQL DA structure. You see how to define. Just for you memory, I show this the truth table for the Boolean operations. You know that Boolean operations in the SQL language is not a binary operations, it's ternary operations always. I mean, it have three kind of results. It could be true, false, or unknown. And truth tables show you how standard defined these truth tables to evaluate expression with this value, these Boolean values. And some examples. You see the syntax is very simple. We can create the table and using new word boolean to define data type. You can insert values with literals or with boolean expressions, as you see, and you see what will be the result of these expressions and how our tool ISTL displays this value, true, false, and null. some more examples. You can see how to test for true value. We can just use it as Boolean expression. We don't oblige it to write where bval is true or bval equal to true. You can just write where bval. It's of course could be used with any Boolean expression, not just with the plain field reference. In the second example, I showed that syntax is false, is true, is unknown is also supported. And in the third example, this is like null arithmetic. It's important to know, to don't forget that unknown values could be compared only with a special operator is. When you use equality or inequality operator, it will not produce results because it will be evaluated to false every time. On my example, look at how Boolean values could be used. For example, in select list, the third expression is Boolean expression. You see how it is evaluated. Just for reference. Well, okay. Unknown, Boolean, and null. There is a mistake because Boolean is data type and unknown and null is the data state. So it could not be compared. And have no difference because of differences. It's like apple and oranges. Okay, forget it. But between unknown and null, there is a difference. Unknown value is the result of some Boolean operations, as truth tables show you. Any comparison with null, for example, is the Boolean expression with the result of unknown. But this unknown exists only until we don't produce the rows. When we produce the rows, this unknown evaluated by engine to the false, and if in where condition we have unknown, you see the third example here, and bval is equal to unknown is itself produce unknown value. But when engine produces the rows, they filter it out the rows. It can't work with unknown. It should work with true and false. And any comparison with unknown or any comparison with null is false. So this is there is not much difference between null and unknown, but null is the state of the data, and unknown is the state of the expression. You can set field to unknown, you can set field to null. Null is the value of the data, unknown is the value of the expression. If some expression has the value of unknown that is going into the, should be assigned to the field, it will assign it the value of null. This? Again, null is the state of the data. Unknown is the value of the expression. We could evaluate null to unknown, but when we show the data, we can't show unknown. If the result of the expression is unknown, we show the null. But in this case, in the third row, we have the value null. Yeah, you see? And when we test null is unknown, we have the true, null is unknown. Yes, it's true by the truth table. I hope it's here. You see the operator if, and unknown here could be replaceable by null, as I remember. So null is unknown, the result of this expression is true, and we return this row. True is unknown, result is false. False is unknown, result is false. Null is unknown, result is true. It's understandable? Or maybe I should express it in different words. No, You can store just null. You can store unknown. Yeah. Unknown is true. Sorry. Again. Back to this example. We have the 3 rows with true, false, and null. And we test this true value with unknown. Using operator is unknown. True is unknown, evaluated to false. False is unknown, evaluated to false. But null is unknown. The only case which is evaluated to true. According to this table. What? Unknown and false is false because this is the nature of the false. If under this unknown is something which is true and false will be false. It's like a multiplication by 0. You can multiply any number, but it will be 0 anyway. Another question?
If you query for each unknown,
yeah.
you always do the same result as when querying for each known?
I think yes. But I should check it. But I think at this time, currently, I think yes. Yeah. Yeah. Equal is not the same as is. Clear? Go to the next part. Repeat please. We just talked about it. Again, unknown is the result of the expression. When we have something which is null and we compare it, it's unknown. But when we want to return the data, we can't return unknown, and we should return true, false, or null, or maybe something else. Unknown is always present in the Boolean expression in the SQL language.
Unknown is a value, not state.
Null, the state of null is unknown. This is true. Well, you can think about the null and about the noun. That this is the equally same thing. And in the most cases, when you don't go into the insight and how it should work and what is some complex research, you can always think that unknown and null is the same thing. Just null can be stored in the database, and unknown is just temporary result for evaluation of the some Boolean expressions. When we want to materialize unknown, it will be null. And okay. Okay, go to the next part about cursor stability. Many people who work with the interface from the first days even could even not know about this issue, but many people which came from another database could see it very fast, could detect it very fast and the new database for them. The most famous example of the cursor instability in the interface in Firebird is the infinite insertion circle when we insert into the table values from the same table. It will never end. If you want to have a fun, you can try it. And it will end finally, but only when space on your hard disk will be half fully. Well, less obvious example, but also with the same root is the second statement where engine will delete more rows than expected. Actually, it will delete rows in the whole table. The whole table will be emptied by this statement. I should say that all DML statements is affected, and insert, update, delete, merge, and all of them. There was many tickets in the tracker created by the different people and different time with different statements and symptoms of this feature, and we decided to create common ticket tracker. You see its number, and link all the previous existing tickets to it to close them all together when this issue will be fixed finally. So why this issue? Why Firebird or Interbase is so bad database, or maybe not so bad? What's the reason of this? If you look how engine internally works with the, for example, into select from kind of statements, it's always create the internal cursor for the select statement. It loops over it, and every found row immediately inserted into the target table. So when this cursor loops over the rows existing at the moment of the start of the statement, it will find the new inserted rows and will again return it to the loop, and it will again insert it, and so on. It will be endless. So basically the main problem is that statement see the rows which is modified by the same statement. This is the main, this is the core of the issue. Update works in the same way. It creates cursor and update rows at the time when cursor produced it. And delete works in the same way. What the standard says? Standard says that rows to be inserted or updated or deleted should be marked first. Standard don't dictate how it could be implemented. It just speak in logical terms. So by the standard we should at first produce the whole result set, which should be, for example, inserted or updated, and only when the whole result set is detected, we should start to change it. So when we change it, the result set which is about to be changed is stable, and it will not be affected by the change itself. If we will implement it in the most obvious way, so mark the result set rows may be stored somewhere, maybe stored with just DB keys. It have some positive and some negative moments. The most obvious and most positive moments from this approach is that row set will be stable, and it will not be affected by the statement itself. So if you insert into table select from the same table, you first evaluate select path, store it somewhere, and then find it in the store and insert the same records again. It will be just one time. But there is many side effects, many negative effects of such approach, of such simple approach. This marks will be saved somewhere, and rows will be visited again. Or we could cache the whole result set and avoid to visit in the rows again, but this result set will be very large and we will spend many time, many disk input output for this statement to run. So this is not a very good approach from our point of view. And again, this could be already reached in the Firebird using loop-noun. I hope loop-noun workaround. For example, if you force the sort in the plan, the engine will materialize this implicit cursor. For example, when you run insert into select from, you can add order by in this select from. You should ensure that this order by will not be indexed, it will be sorted, and in this case, engine really will first produce result set, sorted, and only then this sorted result set will be inserted as new rows. But it will be, of course, much more slower than current approach. But in Firebird 3, we found another way for this to solve this issue. The Firebird always have undo log, internal undo log, which is maintains mostly in memory. This undo log is present with every statement. It's automatic since it could not be disabled. And using this undo log, we know which rows was changed and in the way in which it was changed. We know if a row was inserted or it may be deleted, maybe updated. Also, this is Firebird, this is multi-version system, and we have previous record versions. We have it in memory or on disk or somewhere, but we have it. So, consulting undo log during the select statement, we could know if current row which was found on disk was modified by current statement or not. And if it was modified by current statement, we can restore the previous version, maybe from undo log, maybe from disk, maybe from cache, and use it for this select statement, for this cursor, to make it stable. So, as you see, this approach requires no additional bookkeeping. We don't need to store marks somewhere because we already have it in undo log. We don't need additional storage. And we don't need anything which we don't have now, because undo log is already present. It could not be disabled in any way. And implementation is more or less easy. It's not as easy as it was looks at the first glance, but anyway, it's not very not heavy implementation. But we have some negative side of this approach. For example, inserted records anyway will be visited. For example, we have a table with 10 rows. We may select insert into select from. We insert new 10 rows, but cursor anyway will visit the new rows. It just will ignore it and will not insert it again. But it will visit it when it finds the row in disk. It don't know before it will read it. Is this a new row? Is this an old row? So anyway, it will be visited. Sometimes back versions should be read if we have big result set which was updated or many records was updated. It could be overflow the page cache and records will be stored on disk. For example, if we insert again the few thousand of records, it's obvious that some of them will be on the disk at the time we will visit it again. So we will read these back versions again from disk. But this is not a big problem because if you compare it with standard approach, we anyway will read something. We will read bookmarks, or we will read stored result set. So I don't think it's a very big performance penalty. And the most bad part, as for me, this approach is not work with suspend in PSQL. So if you have, I will show example, if you have suspend in unlucky place, it will destroy current undo log and cursor will not be stable, it will not understand the record. For this cursor, this record will be new always. Not new, but not affected always. Look, if we have such example of code, this cursor will not be stable. But I hope this code is not very often used, and it should be anyway avoided because it have a lot of side effects. We change some values and we read it again, and we don't know what we read again. So if you have similar code, please revisit it and try to avoid it as much as possible. It's anyway not a good code. Also, there could be changes in all behavior because this statement, which have no suspend, it have a stable cursor in the for select statement, and if you expect that you update something and it will be read again and you again update it, it will not work now. So I strongly suggest you to revisit such code when you have what code could be affected. When you have select which works with some tables, and inside the select in the begin and end section you have any modification of the same table. If you don't touch this same table, or if you modify table with the records with the case which is not affected by the upper cursor, you say it's okay. So just programming carefully. This code could have some not expected side effects. Okay, it's all about stability, as I remember. If you have any questions until it's in our cache, please ask us. Okay. The next is improvements in global temporary tables. Global temporary tables was first introduced in the Firebird 2.1, and since then it was not changed much. There was some bug fixes, but basic functionality was the same. In the past years, I remember there was few requests from the users to make some improvements. We implemented, and we like it so much, and it was not very hard to code, so we even backported it into the 2.5.1. So what this improvement was? The most important and most asked improvement was ability to write into temporary tables in read-only transactions. It could significantly lower amount of transactions you needed in the application. This is the widely used approach to have one read committed read-only transaction and to make all reads using this transaction and never committed while the application running. But for complex evaluations, it's often very usable to use global temporary tables to hold the temporary results. In read-only transaction, it was not possible, but now you can use global temporary tables even in read-only transactions. You can change it, insert records, delete, and so on. Implementation have some effect that shows you in this small feature that global temporary tables in the read-only database will be writable only if this is the on-commit delete rows table. So just know about it and plan it to use read-only database, maybe on some CD storage. You should know that not the whole functionality is supported here. Also, we revisited the code for rollbacks and found that global temporary table, which is transaction scope on commit delete rows, will anyway delete rows, so we don't need to undo changes in these tables if transactions is rolled back. Little do you know, when transaction is rolled back and amount of changes in these transactions was not very big, it used its undo log and undo all the changes, and transactions marked in the inventory pages as committed, not as solid bad. It allows to not stack all the syntax and transaction marker. But for the temporary tables, there is no sense to undo its changes, and it will be just removed from the undelog at rollback stage, and this improvement was done. Also, there was changes in garbage collection algorithm for global temporary tables. Global temporary tables is isolated by the attachment at least, so it will not affected by the active transaction in another connections. It have no sense to delay garbage collection in global temporary table if we have all this snapshot transaction which is stuck but is from the another connection. So for the attachment level, we have internal counters of the transaction states, and for the global temporary tables, we have this more exact transaction counters and use it when decide if the question is ready to be deleted from the database. Again, all these improvements was firstly implemented in Firebird 3 and is backported into the 2.5.1, so you can use it even now, the stable 2.5 version. Next is really SQL things. It's about procedure SQL, and this is again long-awaited feature, which looks very simple but cost us some time for implementation anyway. It's SQL functions. Before it, you can write only user-defined functions on external language, which was somewhat risky to implement. It could be written in this way to break the old server, you know. It was not very good portable, so if you write your favorite PDF, for example, in Pascal on Delphi, and you will have the problems to port this function into the macros or maybe on Linux. So people often ask it about the native functions written on the SQL language. And in Firebird 3, we have implemented this feature. It looks very simple, it looks very natural, so I don't know if I need to explain something more about it. Also, there was implemented subroutines. If you program on Pascal language or language like Pascal, you know what subroutines is. The same routines as usual routines, procedural functions, but it have a limited scope. It's declared at the scope of the main routine, and we have access to these local variables and so on. Our implementation is very simple. It's somewhat limited, and at this time declared subroutines have no access to the variables of the parent routine, and it can be recursive. So far, this is the simple example how you can use a subfunction, for example, in execute block statement. Packages. This is the also many times asked feature by many people who came mostly from Oracle, but again, lucky Pascal users could easily understand what is package. It's the analog of the Pascal unit. Package have two parts. It have declaration, it have package header, and it have package body. So far, we support only procedure and function and in packages. We have no package variables and constants or type or something else. I hope it will be extended in the future, but I can't promise. Package body must have implementation of all the routines which was declared in the package header, and also package body could have its private functions or procedures. Also supported forward declaration. As you see, the function f_admin is declared first and implemented later. This forward declaration is usable when you need to have dependent definitions of the functions, for example. And usage is also very simple. You just write the name of the package, dot, and name of the function or procedure from this package to use it. Well, exceptions with parameters. Very nice feature for me. It allows you to not just specify the text of the exception at runtime, but also you can make parameters. You could include parameters markers in the exception text, and when you in runtime raise the exception, you could substitute some values in these parameter markers. These parameter markers have no type, so you can substitute it with strings or numbers or dates or so on. It will be formatted by the engine by default rules and embedded into the resulting exception text. If you need ampersand sign inside your exception text, you just double it and it will be produces the normal text. It's like a quote. Well, at the client side, I have no good example for it, but in the status vector, you could extract the every parameter value. So in the status vector at client side, you will have the exception number as always, you will have the formatted full exception text as always, and you will have in the different slots values for the every parameter. So if you have knowledge about how to work with status vector, you can easily extract the parameters values for your own purposes. Identity columns. Again, this is the feature which was asked by the people from the another databases, but we look at standard first as always, and we found the standard generated by default as identity statement, and we implemented it in this way. So if someone have experience with, for example, Microsoft SQL Server, you see that identity syntax is very different. But it's standard, and we sure that we have the right way to implement it. In standard, generated by is more powerful extension for the data type definition, but we implemented just this, exactly this subset of it. So to define identity column, you should use the whole phrase generated by default as identity, and you see the rules. This column should be a numeric type or integer type. It can be, for example, character type. It has an implicit not null restriction. It's not guaranteed uniqueness. It's easy to understand, but it may be not obvious things. Behind the scene, it's very simple implementation. Firebird just create generator, just create trigger for the insert and update. So this is kind of syntax glue. It's not as something magical. It's for the people who don't understand what is generator, what is triggers, and don't want to write generators every time they need auto-incremented columns. So maybe for the experienced Firebird users, this feature will be less usable, but for the people who came from another database, it could save some time when migrating. DDL triggers. This is a very nice feature from my point of view. It allows you to define your triggers for the different DDL events which occurs in the database. And this is looks like usual trigger, but it definition have no table name because it's for DDL event. You still could define many triggers on the same action, as always was in the Firebird. You can specify position of the trigger. You can activate, deactivate it. So this is usual trigger, but it fires not when the record inserted into some table, but when some DDL event happens in the database. You can specify a trigger for the any DDL statement, or you can specify a set of events you want to track in this trigger. To be it even more useful, we introduced a new namespace in the variables context and defined 3 predefined variables which show you some internal information about environment in where the trigger was fired. It shows you the kind of the DDL event, create procedure, maybe drop table, maybe something else. It shows you object name of the metadata object which was affected by the DDL statement, and it shows you the full text of the SQL query of the DDL statement itself. A little example. It uses exception with parameters, and it uses DDL statement which enforced some rules of naming of procedure. For example, we want that every procedure name will be prefixed by the SP and underscore. So we check if name is not starting with this prefix. We raise an exception and we show in which procedure this exception is raised. One example for the two features. I like it. Okay, no questions. And a little bit about security extensions. In the Firebird 2.5, we introduced ability to manage users using the SQL language. We introduced add user, modify user, and delete user statements, but we forget to have access to the list of the users. And people asked us about it, and we said, oh, we forget about it, you can use Service API, you can use GSEC, but it's not the SQL way. So in the Firebird 3, this gap was filled, and we introduced new virtual table. Virtual table is like the monitoring table. It populates on the first access and remains stable until the transaction end. And this new virtual table has the list of the users from the security database. You see, it has almost the same structure as the table users in the security database, except that it has no password hashes here. It's just information about the user. Of course, a regular user will see just one record in this table about itself, and database administrator will see the whole list of the all existing users in the security database. And I should say that in Firebird 3, using the configuration, we could assign for every database distinct security database. So this table will list users from this personal security database. For example, a database could hold the list of the users itself in this database, in current database. So it will be the users which stored in this database. A bit about database encryption. This feature was committed maybe 1 or 2 months ago. It's very young. It's not fully completed, but it has something about SQL, so I decided to describe it here also. There is 2 new extensions in the alter database statement. You can encrypt database and you can decrypt database. It's the basic operations with encryption the database. A bit about architecture of the feature. The feature based on plugins. Someone should write crypto plugin which will actually encrypt or decrypt database, which will implement encryption algorithms, or maybe it will implement the bridge between the Firebird API and maybe operation system supported encryption algorithms. We have sample crypto plugin code in examples. It's very simple. The feature is run in background and is restartable. What I mean? When you have a database, for example, of few gigabytes, and you run alter database encrypt, and you commit the statement, encryption is started. But you don't need to wait until encryption will be over the 10 gigabytes or 100 of gigabytes. The statement will complete immediately, but engine will start a background process which will read the pages and will encrypt it and save to disk again. And if this process could take some time, if database is big, or if you require very strong encryption, it will be very slow. So Firebird engine will be restarted, maybe because of crash, maybe because of operation system restarted by another reason, and half of the database will be in encrypted state, and half of the database will be in still not encrypted state. This is addressed in our feature implementation, and when Firebird will start again, it will detect that encryption is not done, and it will start again this background process and continue from the place where the encryption stops at previous stage. Yep. By itself automatically. First connect, of course. Firebird can't start itself. I mean, when the first attachment to the half encrypted database will occurs, it will again start this background process and continue to encrypt or to decrypt the database. Yeah. At the header page, we have 2 new bits of the states. We have 1 bit of the final state of the database, encrypted or decrypted or not encrypted, and we have a bit which is show is the process in progress or no. Also, we have the number of the last encrypted page at the same database header. So, if you interested, you could query database header and see the progress of the encryption. But from the efficient point of view, it's not smart to update header with every encrypted page. So it's updated every 1,000 pages, I don't remember. Well, from the user point of view, encryption key is the most important part in any security software. It's not only encryption algorithm itself. Algorithm is well known. There is many good and stable implementation, and we can buy some implementation or implement it by self. But the most important part is the key management. And we decided to not implement our own encryption key management because requirements could be very different in different situations, in different applications. And we implement some API which allows user application to decide, or encryption plugin to decide where to take this key from. The 2 most usable examples is I can speak about is the first when the application have some valuable database, for example, some catalog of materials or maybe something else, and which is distributed on some kind of CD-ROM or DVD disc, and people often want that their database with valuable data will not be stolen by somebody else, and they want encryption. And in this case, it's very logical that only application know where the key is placed, and when application which is distributed with the database is run, it can supply this encryption key to the database. And another example where security encryption could be useful and how it could be implemented is when we have, for example, enterprise with many users, and it's not smart to give encryption key for every user on every user workstation. So we have the way that it's a plugin which make encryption could obtain the key maybe from its configuration, maybe from the registry, from another computer. So it's not necessary application should supply the encryption key. It could be application, it could be crypto plugin itself, which is works, and the database server, and so on. Well, this is the just basic description about it. We expect that Alex will be here in the Luxembourg and will speak more details about this feature, but Alex can't be here, and I decided to at least speak a bit about it. So I hope it was interesting for you. So I'm finished. If you have any questions about these topics, maybe about something else, you are welcome. Yep. Of course, JBack does not read database itself. Engine read database. So, but I already said the feature is not fully implemented. We have a plans that any application could also work directly with crypto plugin. For example, JBack using crypto plugin could produce encrypted backups. Not just encrypted database, but encrypted backup, and JBack could then read encrypted backup, decrypted. Tools for the repairing of database also could work with crypto plugin, and repair and even encrypted database could be repaired using this approach. Yep. Good question. I missed it. No, we decided to not encrypt some kind of service database pages. For example, transaction inventory pages have no sense to encrypt. Currently, it was decided and hard-coded, maybe it will be changed, that encrypted is only data pages, blog pages, and index pages. All other kind of pages is not encrypted. More, the header of the page is also not encrypted. We have a bit in the data page header which show is page encrypted or no. Something else? Yep.
Will they require to when statements are modified? Like you have to require when a feature is modified.
Yeah.
They require when a trigger is modified. Will they require when a CDL trigger?
When the CDL trigger modifies itself? I think yes. Why not? But I did not try it. To be fair, I think yes, it should be fired. Something else you want to know from me? Yes, of course, you could use it as a you can create triggers for the exactly this events, or you can create one trigger for the set of events. If you look at syntax, you see the DDL event item is the list of the DDL event items. Here. Thanks to Adriana for this feature. Oh? It's the same as for any kind of another triggers. So, you mean when you define it or when it runs? When you define it, it's the character set of the attachment which is defined. When it runs, it's the character set of the attachment in which context the trigger is fired. So it's not distinct from any other piece of the PSQL code. Okay, so should I thank you for the attention, or you have another question? Okay, thank you.